Okay, Assalamualaikum. Bismillahirrahmanirrahim. Okay, we start with chapter 2. So, chapter 2, first order differential equation. There are 4 main types of the first order ODE. Are separable variable, linear, exact, homogeneous. Okay, and then the other type is Bernoulli's and separation variables. Okay, now we look at part 1, separable differential equation. Solving a differential equation is often a complicated process. Okay, however, many important equations can be expressed in the form dy over dx equal to gx over fy. Okay, B, to solve such an equation, first separate the variables into the differential form of fy dy fg dx, and then we integrate both sides separately to obtain integrate dy equal to integrate gx dx. Okay, we look at example 1. However, I will show you example A and D only. Okay, then you do it B and C. Okay, for A, you are given 3y squared plus 1 dy minus x squared plus 2 over x cubed dx equal to 0. Okay, first step, we need to arrange the differential equation fy dy equal to fx dx. Okay, so this one is fy. Okay, this one is fx. So rearrange. Okay, next, after rearrange, we integrate both sides. So integrate 3y squared plus 1, okay, respect to y. And then the other side, integrate x respect to dx. Integrate fx respect to dx. Okay, you integrate 3y squared, you get 3y cubed over 3. Plus, integrate 1 equal to y. Okay, equal to integrate. Okay, first this one we write into this form, x squared over x cubed plus 2 over x cubed dx. Okay, then we simplify, we get 1 over x plus 2x power of negative 3. Okay, integrate 1 over x, we get ln x. Okay, integrate 2x negative 3, we get 2x negative 2 over negative 2. And then we simplify both sides, so we get y cubed plus y plus ln equal to ln x minus 1 over x squared plus c. Okay, done. Okay, D, you are given dy over dx equal to x exponent 3x squared cos square y. Okay, same as before, first step we need to reorder into fy dy, and then the other side fx dx. Okay, so we settle reorder, and then next we integrate both sides. 1 over cos square y is equal to secant square y dy equal to, okay, integrate x exponent 3x squared dx. Okay, integrate both sides. Integrate secant square y, we get tangent y. Okay, and then this one, we use substitution method. We substitute 3x square in with u. Okay, so let u equal to 3x square. Differentiate u respect to x, we get du over dx equal to 6x. Okay, and then substitute dx with du over 6x. And then you cancel off x. Okay, integrate this one. So you get 1 over 6 exponent power of u. Okay, substitute back u with 3x square. So the last answer will be tangent y equal to 1 over 6 exponent 3x square plus c. Okay, example 2. Find the particular solution for dy over dx equal to exponent power of negative y sin x. Okay, given that y pi over 2 equal to 0. Okay, this one means y equal to 0, x equal to pi over 2. Okay, next dy over exponent minus y, exponent power of minus y, okay, equal to sin x dx. Okay, next, this one we write as exponent power of y dy. Okay, so we integrate both sides, integrate exponent y dy equal to integrate sin x dx. Integrate exponent y, we get exponent y. Okay, integrate sin x, we get negative cos x. Okay, then we substitute y equal to 0 and x equal to pi over 2. Okay, after substitute, we get c equal to 1. Okay, and then exponent, we substitute c into this equation. Okay, substitute c into this equation. So, our particular solution is exponent y equal to negative cos x plus 1.